Alright, here is your video for retake learning target 7. Explain operations on irrational and rational numbers. And if you remember the kind of definitions of irrational and rational numbers, we talked about a rational number as having a decimal that either repeats or ends, okay, and an irrational number that does not have a repeating or ending decimal. Okay, so those two definitions are going to be very important when talking about operations on irrational and rational numbers. So here were the two problems that you had on your test. Number 17, explain why the sum of a rational number and an irrational number is still irrational, and then give an example to support your answer. So the sum of a rational number and an irrational number will still be irrational. You could give a reason like because the decimal will still be never-ending or not repeating or something like that. So the decimal will still not end or repeat. And you can give an example of something like, maybe you start with like pi as your irrational number. If you add a rational to it, so if we do pi plus 3, it will still be 3.1415 ... Adding 3 to it just makes it 6.1415, etc. Okay, you still have this never-ending, never-repeating decimal. Okay, and that's why it stays irrational. Similarly, down here then on number 18, explain why the product of a non-zero rational number and irrational number is still irrational. If you want to do like pi times 3, you'll have 3.1415, etc., times 3, which then would, make it 9.42, etc. But this decimal will still never end or repeat. You multiply each part of the decimal by 3 by this rational number, but it will still be never ending, never repeating, and therefore it will stay irrational. Okay, so for the before you take the retake for this learning target, come up with a couple examples on your own that will support this. So maybe it's not pi times 3, maybe you do a different irrational number times 4.5 or something, but come up with your own example to support why the sum or product of a non-zero rational number and an irrational number remains irrational.